Swayam Prabha. Digital India. Educated India.
Welcome back, my dear students. This is the continuation of the project management course. This is the 30th lecture which I am going to start now. And if you remember, I did mention very briefly that why the crashing of the jobs would be required. Crashing means you want to reduce the time, and obviously then you need to basically consider what are the resource constraints or the resource implications which you have for your problem. So, continuing with the same discussion, the project has now, with some of the reasons which we are discussing, the project has slipped considerably behind schedule and you need to basically crash the set of jobs or the activities to finish the work on time. So, in order to catch up, we meet our milestone and the deadlines, we have to speed up the work of the project. The contracts provide, there may be such cases. So, I am just reading out some of the actual reasons why you may be interested to crash the project or the set of activities. So, the fourth point is the contracts provide incentive to avoid scheduling slippage. For example, suppose we were faced with stiff penalties for every day the project is delayed. So, I did mention this point that if you are able to deliver, for the last example which we considered in the 29th lecture discussion, the average time was 30 weeks and somehow the contract was such that it was said that if you are able to deliver within the 32 weeks, you get some benefit like some extra income or some bonuses you can get. I am just, or say for example, you are assured that you are competent enough to get the next project in hand. But on the flip side also, if you exceed the 32 weeks deadline, there is a penalty. Penalty can be you have to pay a huge amount of cost or the overall price deduction would be there. The depreciation concept would be coming into the picture where you make a loss. So, these may be some of the stiff penalties which you as a project manager or a team leader can face, for which you have to take a decision whether it is actually feasible to crash the set of jobs for the project. So, let us consider the graph which is there in front of us, which is the 363rd slide. So, on the y axis you have the cost. So, I am considering the cost overall, it is nothing to do with input cost or output cost, I am just considering cost as a factor, point 1, and along the x axis I am basically considering the duration in days, in weeks, whatever it is. Now, there is only one important point to be mentioned, I am considering the concept of the relationship between the cost and the factor of time is linear in nature. So, if you consider point number A, so point number A is not marked here, I will basically mark it here, consider point number A is here. Point number A is nothing to do with the activity, nothing to do with the job, it is basically a point here in this curve, and this point B is there. So, you can basically use any other alphabets to note that. So, what is important is that consider point number A. Point number A means because it is where you will basically try to go on the cost concept corresponding to the fact that you have been able to reduce the time. So, you will ask your question, and this is for each and every activity, not collectively. So, if you consider the overall normal work going on, so the normal cost is here and the normal time duration is here. So, if you consider the overall project or set of activities, the total cost comes out to be as given in point number B. Now, you want to basically reduce the number of days. So, the reduction of the number of days is, consider this is T2 and this is T1. So, you would reduce it from T2 to T1, but the cost concept which was basically initially C2 has to basically increase to C1. So, what you are interested to find out is that what is the rate of change of this cost, such that if you are decreasing the cost from 10 to 5 days. So, there is a 5 days reduction. So, you will try to find out that what is the overall cost implication from that project for those 5 number of days. So, if you know per day increase in cost is 100 rupees, so it will be 5 into 100. But the things are not that simple. Reason is, I will give you two broad reasons which would make sense. Number one is that the cost concept which you seeing here in this graph is linear. In our case is not linear in the practical sense, it can be non-linear. So, actually it would happen is that more you crash it, more amount of materials, man and financial resources have to be used. So, it will be increasing on a higher quantum as you reduce the number of days. That is number one. Number of point 2 is that if you remember when I did mention about trying to find out the variances, we did mention time and again that we consider the jobs or the activities or the tasks are independent on each other, such that trying to find out the variance by adding up the variances of all the activities which is there on the critical path holds true. But that may not be the case, because they would be interdependence between the activities and the jobs. So, those two are the main important point which needs to be assumed not to be true, based on which we are trying to basically proceed and solve the problem. But that will give you the way we try to basically tackle, or what I discuss would definitely give you a much better feel that how it can be done for nonlinear costs also. Now, what the graph which you have in front of you, which is the 364th slide, is basically gives the resource leveling and resource allocation graph. So, again I have on the along the x axis I have the time. So, when you are trying to finish the time, and on the y axis rather than the cost I am trying to basically draw the resources. Now, resources what I have marked is that there are 2 points. So, these 2 points are just to give you a feel that what is the maximum, the minimum amount of resources which you can utilize, and it does not mention anything about the early start and the early finish, or the late start and the late finish. So, that would also come into the picture. So, even though I would not be discussing the graph, but I will try to basically dictate to you, tell to you, such that you will appreciate that how things can become complicated as you bring all more practical situations into consideration. So, if you see the y axis, there are 2 points, capital R and small r. Capital R is the maximum amount of resources you can use for any activity of the set of the jobs which are there at hand. Consider you have 10 different excavating machines, or in the factory you have 3 different CNC machines, you cannot utilize more than 3. Or consider you have about 100 different type of skilled laborers who are there in the factory. Or say for example, consider you have lorries, number of lorries which you have to transport material from your go down to the actual site is, say for example, 20 in number. So, this capital R is that number which I am talking about, and also consider that small r is the total minimum number of resources which you can use. So, I will just give you an example. Say for example, you in the total number of workers which I did mention just a few seconds back, consider in a factory there are 10 number of actual permanent labor, and the rest are all temporary staff, and due to some reason you cannot fire those permanent laborers, which means that the total number of resources which you can use from the labor point of view is 10. So, this capital R and small r basically gives you the maximum amount of resources, any resources which you can use, and small r is the minimum number of resources you can use. Point 1. Point number 2 is that the resources the graph which you have in front of you is not the combination of all the resources, is basically, if you want to go in a micro level, it will be the resources collectively in the sense manpower as a resource, and you try to basically find out that what is the usage of manpower throughout the project, with time being noted down on the x axis. Or resources can be number of lorries which you have, resources can be number of CNC machines which you have, resources can be number of computers which you have, whatever it is, or resources can be number of design engineers you have. So, if you see this graph and the graph, this is the sort of step function which you have, where I am trying to basically move my pointer, it basically means that the resource usage is in such a way that you will basically have 2 areas which needs to be taken care of. The first area which I am now highlighting with my yellow highlighter is the set of areas at some point of time where you think you will be utilizing more than the required maximum amount of resources. And if you see the other part, which I am now going to hash, use the red color, are these portions where my utilization of resources are below normal. So, consider this case, I am only concentrating on the CNC machines, consider as arbitrarily, and my resources are the CNC machines. So, if I see the yellow part, it may mean that I may have to basically offload some of my work to a vendor who has that type of CNC machines and who can give me the services for the project which I am trying to implement. So, there the overall cost which I need to basically utilize in order to offload that quantum of work to the vendor can be found out for those portion which is marked in yellow, fell pen here or yellow color here, such that I can try to find out that if I offload that work to that vendor, what is my cost, and also consider that if I am trying to crash the job and try to find out, get the best benefit, whether I am able to offset that overall cost by giving it to the vendor by the overall incremental profit which I am going to make. If that is true, obviously I will go for that. So, consider now the second point, which is the red hashed area. So, red hashed area which I have in front of me would be, consider not the CNC machine, is then the laborer for the time being, and I am only concentrate on underutilization of the resources. So, if I think that the number of workers needed in a certain period of time which is in the beginning of the project is very low, what I will do is that I would not hire those temporary workers then. I will basically start hiring the temporary workers after a certain stipulated date, such that I do not have to pay any extra amount of salary or remuneration to those set of people who I will basically hire later on, such that I am able to offset the extra amount of cost with respect to the profit which I am going to make. So, these two examples, even though they are very simplistic in nature, would give you an idea that how the overall resource allocation graph would be utilized for each and every resources for the project, considering time is there along the x axis, so that I can make a one-to-one comparison, whether resources I have to basically hire or whether the resources which I have to have in my case and I want to reduce it, I can offload temporarily, such that I am able to balance the extra cost with respect to the profit which I intend to make by crashing the jobs. Now, in the same way, the graph which we just discussed in the 364th slide, let us consider along with the 365th slide which is there in front of us, it gives us the cumulative resource requirement curve. Now, if you do remember, I have paid attention when I was discussing that 364th slide, I did mention this is the resource allocation graph for any resource with respect to time. Now, those type of resource allocation graph can be made for the early start and the late start concept also. So, now coming back to the early start or late start, if you remember, when I am trying to find out, use the concept of forward pass method and the backward pass method, and based on that I use the concept of early start and the late start, and then try to balance and try to find out what is the total float and the free float. I did find out that total float and free float, as you would immediately say, that it would be non-zero for those non-critical activities and 0 for the critical activities. Now, if I am able to draw the early start and the late start total cumulative resources for any resource, that will give me in a way that what is the gap which is happening or extra utilization or less utilization of the resources which would happen if I try to combine both the concept of the early start and the late start for any activity or combination of the set of activities which are there in front of me. So, now let us consider the usage and try to discuss in a very simplistic sense how this early start and the late start cumulative resource allocation can be utilized. So, now two important points. Along this y axis I have the total resource requirement. So, let us mention it resource. So, resource I am just mentioning in a very simple way as I discussed in the 364th slide, was basically utilization of man, utilization of machinery, utilization of vendor, utilization of dumper trucks, utilization of say for example, cranes, whatever it is. I am just discussing the production from a production point of view or a construction point of view. Now, if you see the bold line, which is the early start cost, it basically starts at point 0, which is A, I am marking here, and it ends at basically at point B, which is the topmost part. Now, if you consider the late start also starts at A and ends at B. So, even though it would not make much sense, but I am trying to basically draw a parallel with these graphs with the cumulative distribution graph which you see in probability. So, the cumulative distribution graphs basically starts from a point of 0, where the overall sum of the probabilities at x, its minimum value is 0, and it goes and increasing till the maximum value, which as you always know should be 1. So, what we have is this, considering discrete or continuous, that does not matter for the distribution. So, for the value of x minimum till x minimum, if I add up f of x dx, this f of x dx is the PDF for this distribution, this value is 0, which is this point. That means, I am not trying to utilize any sum, add the sums of the probabilities. So, here the resource allocation or utilization is 0. And if I add up all the probabilities, which is from x minimum to x maximum, so f of x dx is basically 1, so which is point number B. Now, the area which you have in between would give you in a nutshell the overall utilization and less utilization of the resources which you would basically incur considering the early start and the late start concept which is there. Technically, you would always try to go through a concept where the linear graph is used. If you remember the cost structure, I remembered from the crashing point. If you see and if you can remember, this is the crash point, this is the normal point, and these are the times. For the normal time, this is the time which I mentioned as T2, this is the time which is basically T1, this cost and this cost is given. So, I am considering where I am highlighting. So, let me highlight using the highlighter. So, this part was linear. So, if it is linear, what actually I would try to do is that try to find out the best fit line between point A and B such that the overall cost implication is as linear as possible, such that I have an idea that what is the marginal rate of increase and decrease of the cost for the project, such that I can utilize resources in the best possible manner considering the early start and the late start concept. Now, I will pause here and give you some more details. If you remember the concept of PERT or the CPM, critical path method, I did mention 4 different ways of trying to basically align the jobs of the activities. One was basically end to start, that means ending of A being the previous job, B being the later job. So, as A ends, B starts. So, there is a number of days which is there, and that is the concept based on which we drew and solved all the problems for the PERT and CPM. Another concept which other 3 concepts which are a part and parcel of general project scheduling and project management, but we did not consider, but we did mention that how the calculations can be done, was basically the end to end, which was if you refer to the slides you will or the diagrams you will understand. One basically was from start to start, that means the first start I am saying is basically for A and the second start is for B, and another was basically from start to end. So, start being for A and end being for B. So, these 3 different ways of trying to analyze the jobs were not considering in the calculation for the PERT CPM, we only considered the end to start. So, the graph which you have in front of you in the 365th slide considered the early start and the late start concept, considering that the jobs, one job B can only start after job A is finished. So, if you basically consider all the 4 concepts in the picture, you could have different ways of trying to interpret how the cumulative resource requirement curves and how the crashing concept can be considered in a very simplistic manner. Even though Complications would be there if the number of jobs is very high, but it will give you an idea that where the crashing, where the extra resources can be utilized, or where the less requirement of the resources are, such that you can plan your activities accordingly. So, resource constraint creates two types of problems: resource leveling. So, you have to level the resources, because any extra amount of requirement resources or below the requirement resources on an average entails a cost. As I mentioned, extra amount of resources means you have to offload it to the vendor. Less amount of requirements would be that it may be possible that those are permanent workers. I did not mention about the permanent workers, I just told about the contractual workers. The permanent workers have to be just kept sitting idle, such that you have to pay their salary, pay their benefits, whatever it is, till you are not getting the benefit of the work from them. So, resource leveling has to be done. The problem is to obtain the best possible smooth resource profile over time, such that, and this is what it means, the project deadline is fixed. So, hence you have to basically adjust the resources in the smooth way, but the resource capacity level might be adjusted in order to meet the deadline in the best possible manner. Resource allocation has to be done. So, the problem is to obtain the shortest possible project duration, considering the crashing and all these things are possible. So, there is a given limit for the available resources. So, because there is a capacity limit. So, all this work which you are doing based on the fact that you want to find out the critical path does not assume that resources are a constraint, but if you bring that in the picture, then these realities really slowly seep in, such that there is capacity limit which cannot be exceeded. However, the project duration might be adjusted to accommodate this fact into the picture. The solution algorithm for these types of problems fall under two main categories. One is the decision based, which are algorithms where the solutions are justified because they appear reasonable. So, what solution of the algorithm which you have for one problem, depending on the concept that it is the end to start for the idea how the jobs and activities are placed, may not be applicable for the case when you have the end to end concept being utilized. So, you have to be very careful that what algorithms we use. There are a whole bunch of algorithms. I cannot promise that I will be able to finish everything, but I will try to give you an idea about that. And another are the optimization based, where the algorithms are which are the algorithms seeking in a mathematical optimum solutions according to the given optimization criteria or the set of such constraints which you have. So, if you are able to solve a certain optimization problem, so those sets of problems which have the similar properties can also be solved using the optimization techniques which you may be tempted to use. The classical theory gives us two approaches to scheduling activities in a resource constrained network. One is the serial concept, one is the parallel concept. So, in the serial concept, the serial method ranks the activities according to a chosen criteria. So, whatever the criteria is, whether the costs are very high, costs are very low, whether the sophistication of technology is very high or the sophistication of technology is very low, or whether the weather conditions are such that you have to basically take that into consideration, whatever they are, we basically you rank them the activities according to those set of criteria which is there, or set of such decision variables which are there. So, after that you schedule those activities one by one in the ranked sequence. So, consider you have 10 different CNC machines and the jobs are ranked. I am just using the very simple concept of A, B, C, D. So, first you will basically utilize it for A, then depending on whatever resources are left, you will basically come and utilize those resources which are the CNC machine for job B, and so on and so forth, go accordingly. The resource requirements is compared to the available resources. So, what you will try to do is that first try to use the small concept of trying to basically rank them from the highest priority to the lowest priority and utilize the resources accordingly, and then try to see whether that is physically possible. So, if you think that the resources are to be utilized for the CNC machines for job A, B, C, it may so happen that if you try to utilize for C, the resources are all exhausted, or say for example, it may be possible that the materials are not available, in the sense some very specific tool which you are trying to utilize for this CNC machine, that may not be available. So, in the practical sense you have to basically understand those concepts accordingly. So, if there are not sufficient resources available, as I just mentioned, the activity is gradually moved to the later positions until the resource limit is not existent and planned accordingly. So, if you see the resource utilization, so there were some peaks which was over and above capital R, there were some values which were below small r. So, what I am trying to concentrate is that what are the areas which are above capital R, and basically you will try to analyze your problem accordingly. So, if necessary, the project deadline may be required to be extended such that you are able to solve the problems accordingly in a practical sense. In the parallel concept, the parallel method splits the total project time into number of intervals. So, basically divide the overall job into some intervals depending on what you think is important, where you can take a decision based on the past work which has been done, and then re-look at your strategy in trying to basically analyze the resource allocations and the resource utilization, because your main two criteria would be you need to crash the jobs due to whatever reasons as I mentioned, and you want to basically level the resources in such a way that utilization is optimal and you are not under the jurisdiction where cost implications becomes very high such that it eats into your profit motive. Within each interval the serial method is applied in the scheduling. So, for you break it into time frame and then utilize the jobs in those intervals and see whether the resource allocations are exceeding or they are within limit. If an activity cannot be scheduled due to lack of resources, it is postponed to the succeeding period. So, in the same way as in the serial method, if resources allocations are exceeding, you pass it on to the next level and then see whether resources are available. In the same way, time slots are there in the parallel one, you do the serial one for each part. If any part or any activity or job cannot be accommodated in one of the set of the parallel set of jobs, you pass it on to the next level, but obviously keeping in mind what are the precedence concepts, whether the jobs are very necessary or whether the later jobs would not become critical, and all these things have to be considered. So, there may be different priority criteria for different jobs, as I just mentioned, like say for example, if job D is very important before E and F can be used or they can be started, obviously priority has to be given to D in spite of the fact that C is basically before D. So, consider the sequences C, D, E and F following D in whatever sequence it is. And then if I need to basically reschedule D, it will have a huge impact on E and F. E and F can be, say for example, I call for a special machine from a vendor. So, if E is delayed, I have to basically talk to the vendor and delay the delivery of this machines, very special machine, by a certain number of days, because if I get it beforehand, obviously I have to entail a huge amount of cost. So, the crashing of the jobs, I will just give you a brief background of the problems which I am going to consider now in the 31st and the 32nd. So, I will discuss the background of the problem. So, the symbols are in the first column are A, B, C, D, which are the jobs, whether you do in the activity on node and activity on arc, that does not matter. The normal time of the costs are given. So, you have basically the normal time is 9, for A you have 9 and slash 10 is the cost. So, I am considering cost as linear, marginal rates are linear, not any nonlinear function. Similarly, for B it is 8, 9. So, 8 and 9 is basically the time and the cost. Similarly, for C it is 5, 7, D is 8, 9, E is 7, 7, F is 5, 5, G is 5, 8, and the crash time and the jobs are given. So, which means that normal cost is for job A is 10 for a normal duration of 9, and if I crash the job A, which is activity A, to 6 days, the cost is basically 16. So, I need to find out the slope. So, the slope is calculated very simply, 16 minus 10, which is 6, divided by 9 minus 6, which is 3. So, 6 divided by 3 is 2. If I go to the last one, let us go to the last one, which is job D, it is 23 minus 8, which is 15, 23 minus 8, let me write it down, and the last is 5 minus 2, which is basically also here it is should be 5. So, I will just recalculate it. Anyway, I will try to basically have a look in this 371 slide and come to that. So, let me continue. So, these slopes are basically means they are marginally which are fixed, they are not non-linear. So, the slope which you have which is in the last column, the normal cost and the crash cost and the time are accordingly given here. So, this is the crash point, this is the normal point, the slopes which I am talking about, which I am highlighting time and again here is these values which are given. So, with this background I will close this class and continue with the 31st class later on, but before that I will again in the 31st class I will again discuss this slide and continue the discussion how you basically simply tackle the concept of crashing of jobs and resource allocation from a very simplistic point of view, and obviously it will give a good idea how it can be done on a practical sense. Have a nice day and thank you very much.